Greetings, traveler. I'm the calculus cleric, and today we're working with sequences. So the specific problem is to find the value of the limit and infinity of the sequence square root of 3, comma, square root of 3, multiplied by square root of 3, and so on and so forth. Now, let's call this sequence a of n, and they're asking us to find the limit at infinity. So limit as n approaches infinity of this, and let's call this whole thing L, because if we look at this sequence itself, we can't seem to figure out an easy way to analyze this without having to resort to some kind of algebra at the end. And we can resort to algebra using this variable, and it's way easier to cite the variable instead of this very long, complicated bunch of terms. And so the easiest way to do this is to just square both sides. I'm just going to walk through the process. And once you square both sides, a of n will not remain the same, because a of n squared will get 3 comma 3 square root of 3 square root of 3 square root of 3, and so on and so forth. So for me, it was actually easier to look at this backward. The limit as n approaches infinity of a of n, what makes that equal to the limit as n approaches infinity of a of n squared? Now, we want just the regular limit as n approaches infinity of an, not the squared value, because they're just asking us to find this sequence. So the regular a of n sequence, not the squared one. So if we notice, a of n squared has an extra 3 compared to a of n, and so I can multiply my a of n with a 3 to get to a of n squared. But that leaves me with a problem, because it essentially does this to a of n squared, and we can't have that 1 in the front. So what we have to do is we have to shift over a of n to be a of n plus 1. But the good news is that since we're taking the limit as n approaches infinity of a of n, we don't have to worry about whether a of n is shifted over at all. When taken to the infinite limit, that value will both be the same for both of them, since we're just shifting terms around on the same sequence. But because infinity goes out to forever, they'll both end up converging at the same point. So now we can replace that with L, and so L squared is equal to 3L, and L is equal to 3. So limit as n approaches infinity of a of n is equal to 3. But hold up a minute. There's another solution you might have seen by changing this to that, and then factoring out an L, which will give you L is equal to 3 or 0. Number 1, this sequence is positive. As you can see, there are no negative terms in here. And number 2, it's increasing, because the square root of 3 multiplied by the square root of 3 is bigger than just root 3. And as you notice, they keep multiplying on extra terms, which will gradually make this a of n larger and larger and larger. So it can never be less than its starting term. L will always have to be bigger than the square root of 3. It can never be less than that or equal to that, because that's our starting term. And it has to get bigger than the starting term somehow. So L can only equal 3.